All right, there's another definition for the shape of skewed distributions, and that is skewness. So skewness is the degree of asymmetry of a distribution. So symmetry means it has symmetry. It has like a mirror imaging. Asymmetry means lack of symmetry. All right, so if something has zero skewness, then it's a symmetrical distribution. A distribution with large skewness casts doubt on the normality of a population. So let's look at two examples here. We have random variable x, which stands for retiree sleep time. Okay, so here's the data of 24 retirees that were asked how many hours of sleep they get every night. And then we have random variable z, which stands for student sleep time. 24 students were asked how much sleep they get every night. And this is the data for those 24 students. And if we take each of those and we graph them, here we've got a histogram of retiree sleep time. And you'll see that we no longer have a line of symmetry. There isn't a line we can draw through the middle where it's the same on the left as it is on the right. Right? And you could try this. You could try drawing a line of symmetry maybe right here, but then, is what we have, the shape on the left, the same as the shape we have on the right? It's not. So we no longer have a line of symmetry. Instead, this distribution is skewed. Now, it is skewed in a particular direction. So well, let me talk about that here next. Let me contrast it here with the next one. So here's the histogram for student sleep time. And you can see too, there isn't a line of symmetry we can draw down the middle where it's symmetric on one side, just like on the other side. Okay, or, if it has this shape on the left-hand side, it does not have that shape on the right-hand side. All right. So both of these are skewed. Okay, they're both missing a line of symmetry. Now, the top one is called, sorry, the one on the left is called being left skewed. And if it helps you, you can think of a skewed distribution like this as being similar to your left foot, right? So where you've got, the little baby toe here on the left edge, and it kind of goes up to the big toe and then kind of comes down right away. And so that's very similar to the shape that we have here with this distribution is you've got the little baby toe and it's kind of going up all the other toes until you get to the big toe and then it comes down. Okay, that's very similar to this. So you could think of a distribution that's skewed like this as being left skewed because it very much looks like the orientation of your toes on your left foot. Now, the other histogram, the histogram of student sleep time, that one is right skewed because again, it's following the shape of a human right foot. So you can see you kind of come up and over the big toe, and then you come down the other toes, and then finally to the baby toe on the end. So you kind of come up and over the big toe, and then you're coming down over the other toes, and then ending with the baby toe there on the side. And so this is an example of a distribution that is right skewed. So another way to think about it too, as far as it being right skewed, is, imagine if this was symmetrical. So if this distribution was symmetrical, okay, it might look something like this. Let me use a different color. It might look something like this. But if you took the right-hand side and you pulled it outwards, right? Now you're pulling it out to the right, and it's going to look like that. So that might be another way of thinking about this being right skewed. And then likewise with this one here on the left and this one being left skewed, if this was symmetrical, it might look something like that. But if you grabbed the left-hand side and you skewed it to the left, like that, then instead you would get a distribution shape that looks something like this. So that is skewed to the left. Another way to refer to it would be to say that it's negatively skewed because it's going in a negative direction. The other one, another word for it, is positively skewed because the values are being pulled in a positive direction. And the way I'm defining positive and negative direction would be like if you had a number line, right? And there's positive numbers to the right and there's negative values to the left. So going in a positive direction, going in a negative direction. Okay. So this, seems to be a good way to remember, what we mean by left skewed and right skewed. It's just to kind of look down at your foot and see if the distribution that you're looking at matches the pattern of the toes on your feet. Okay. Otherwise, you could just think of grabbing the left-hand side of a symmetrical distribution and pulling it to the left, or grabbing the right-hand side and whether it looks like it's being pulled to the right. And failing that, you could also think of it as it being stretched in the negative direction versus being stretched in a positive direction. All right, let me know if you have any questions.